Sorry, guys, I cut off halfway. So we'll finish the rest of the lesson in this part two. So we were talking about how our h shifts us left or right. The other piece that I wanted to talk about is our k. I'm going to call it k because it's outside of our argument. That shifts us up or down. And when I mean up or down, I mean it is taking this original point and moving it down. That's all it does. And if you notice, it moves every single point the same distance. So these transformations are moving everything. If you remember your geometric shifts, all this is doing is moving all of our points down that much. So let's try a couple. This one I want to talk about. I want to talk about a couple of these so that when you guys get to your homework, it's not as traumatic for you, okay? So we're going to graph these, or we're not going to use any graphs for these. We're going to just tell me what the domain, range, and asymptote are. Well, I know that the domain is the same as my asymptote to infinity. And my range is always the same. It's negative infinity to positive infinity. So this is my range. Leave my domain for a second. My asymptote is, the way I'm going to do this, remember that my argument has to be greater than 0. The reason it has to be greater than 0 is because at 0, we hit our asymptote. So I'm going to set my argument equal to 0 and solve it. So this is going to be x minus 5 equals 0. This becomes x equals 5. That is my asymptote. My asymptote is at x equals 5 because I can't go lower than that. It's the lowest I can go, which means that our domain is also going to be 5 to infinity. Okay? The last piece is here our x-intercept. Remember that our base x-intercept is 1, 0. Okay? And that this represents a horizontal shift in the opposite direction that we think. Just like when we first did our transformations of quadratics, the negative h moved it the opposite way that we thought it was going to. So the negative 5 is actually going to add 5 to our x value. It becomes 6, 0. So this is my x-intercept, my asymptote, my domain, and my range of this function. No wrapping it. Let's do the same thing again. So my argument is going to be at 0 when x is 0. That's where my asymptote is. So my asymptote right here is x equals 0. My domain is my asymptote, so 0 to infinity. My range is always the same, negative infinity to positive infinity. And my intercept, my x-intercept, is going to be 0, 1 shifted down 2. But that's not going to give me an x-intercept anymore, right? I'm not shifting it left or right. So the new trick is I'm going to set this function equal to 0. I'm going to set log 4 of x minus 2 equal to 0. Okay? Because all of my x-intercepts, all of them will happen when y is 0. This line is my x-intercepts, all of them. Okay? If it ever happens, it happens on this line. We just don't know where yet. And that is y equals 0. So I'm now going to solve this function. To do that, I'm going to move everything away from my log function. I'm going to add 2 to both sides. And that gives me the log of 4 to the or 4 of x equals 2. Okay? I can fix that. I can do a simple loop conversion here. Convert that to an exponential so that you'll understand what I'm about to do. This is going to become 4 squared equals x. So remember that I put in my table, essentially, I put in that y is going to be 0. I know it's going to be 0 because that's where my x-intercept is. I just have to figure out where. Now I'm going to find an x. 4 squared is 16, so that is my x. Okay? And a general trick that you can do for these, you won't always get a clean answer unless you're picking specific numbers, is you're going to pick y values and get your x's later. Okay? The way that works is I'm going to play around and say I want to know when y is 1. Where is x? Right? Well, I can plug that in. Log of 4x minus 2 is equal to 1 now. And then that will be log of 4x equals 3. And that will be 4 to the third equals x. And that'll give me an answer too. So I can get answers by plugging in my y's now. Whereas with my exponential function, I plugged in my x's and got my y's. So we're working backwards. Just keep thinking about inverse as a way of flipping it around. So what are the important ideas I want you to understand? This is the general formula that I want you guys to be thinking about. I'm moving things up and down, or left and right, up and down. The x minus h part, this parentheses, is always going to be called my argument. And if I could spell it, that would be great. Okay? It has to be greater than 0. And I know on your notes there's not enough room to write greater than, so you can just write the caret there. To find our asymptote, we're going to set our argument equal to 0 and solve it for x, okay? I'm going to set x minus h equal to 0 and solve it. Exponentials and logarithms are inverse functions. Inverse functions. We've already talked about that a million times. We can keep hitting it until it's, eaten into those brains. They are reflected over the line, y equals x. Each point on our exponential graph, I'm going to call that a comma b, is mapped to a point b, a on a logarithm. That's just how we define that they are inverse. And to find the x-intercept, which is the other piece, so we have our argument and our x-intercept, we set the entire function equal to 0 and solve. Okay? Now I want to go over a couple other things, part of your homework real quick, since we have this whole big chunk of time, right? There are some easy numbers that you can always find. Okay? There are numbers that you can always find. And that is when your argument is equal to, so we're going to put x as h, equal to a couple of things, okay? 0, because that will give us our asymptote, our vertical asymptote right here. 1, okay? So when I ask you to graph these points, these are the easiest ways to find points, okay? And then we're going to use one more, the base. So whatever our base is, this is our base, b is our base. So whatever number is your base, I want you to set it equal to those three things, because these are real simple. Let's say I have the log function of 3 to the, I don't know, let's say x minus 2 plus 2, okay? And I want to graph that function, all right? I'm going to use these three to get me 3 easy points, the vertical asymptote, the first point, and the second point, okay? So the first one I'm going to do, I'm going to set my argument equal to 0. X minus 2 is equal to 0. When is that true? When x is 2. Okay? So right over here, I'm just going to keep track of what I'm doing. Okay? And then I'm going to pick when it's equal to 1, so I'm going to x minus 2 equal 1. And that is true when x is 3. Okay, so I'm going to pick 3. And then I'm going to pick the base, which is 3. So 3 minus 2, or when is, x minus 2 minus 2, gosh, equal to 3. Okay? Well, that is when x is 5. Okay? And I'll show you why that works here in a second. So let's plug these numbers in, 2, 3, and 5. All right? So we'll make our function. Sorry, I forgot to make our function here. Log 3 of x minus 2 plus 2. Log of 3, and I'm going to put my first number in, which was 2. 2 minus 2 plus 2. Okay? Well, 2 minus 2 is going to give me log of 0, log of 3 of 0. Okay? That's impossible. This is my error, so this is going to be 2. This cancels out and becomes a 0. So that is where my vertical asymptote is at. When x is 2, we have nothing. This is my VA right here. Oops, sorry. Keep it. No! We can fix this. Sorry. It's not 2, it's an error. This is our VA. This is where we get to, but we never reach. So we're going to draw on our graph. I'm going to go over to 2 right here, and this is my dotted line. Okay? Log of 3, remember I'm picking 3, minus 2 plus 2. Okay? Log of 3 minus 2 is the log of 3 of 1 plus 2. Okay? So what is this right here? This is 0, right? What do I have to raise 3 to get 1? It's always 0. 0 plus 2 is 2. Okay? I can show you that a little bit more in depth right here. This becomes 0 plus 2, which is equal to y. Okay? And then finally, I'm going to pick 5, right? So log of 3, 5 minus 2, plus 2. Log of 5 minus 2 is the log 3 of 3 plus 2. Well, the log of 3, that is 3. What power do I have to raise 3 to get 3 is 1. So this becomes 1 plus 2, which is 3. Okay? So that is the quickest and simplest way to go ahead and graph these 2 or 3 functions on your homework. Good luck. If you have any questions, feel free to reach out. Have a great day.